Supersize Me is the title of a documentary film about what happens if you eat only McDonald's for a month. It's also the title of this talk about natural language processing models in 2020 and beyond. Natural language processing, or NLP, is a promising field within data science. Since the release in 2018 of Google's BERT model, the performance of these machine learning tools has improved by leaps and bounds. Yet innovation in this field seems to have stagnated. The performance improvements are drawn largely from simply increasing the size of the models running already existent techniques. So what we've ended up with is a series of bigger and bigger models that are more expensive to pre-train, and therefore innovation in this field is increasingly limited to a small subset of well-funded organizations. This year, OpenAI released GPT-3, an improvement upon their prior efforts in this space. With 175 billion parameters, GPT-3 is a huge model. We'll talk about some of its capabilities in this presentation, and we'll also cover some of its limitations. Most importantly, I want to address the impact of this avenue of exploration, namely creating bigger and bigger models, on progress towards the ultimate dream of creating artificial general intelligence. The latest OpenAI model is available through an API, though accessibility is limited to a waitlist. Like its predecessors, GPT-3 is based on the transformer architecture for neural networks. This architecture dates back to Google's BERT from 2018. There doesn't seem to be much in the way of innovation in terms of the underlying architecture, though of course this is difficult to tell because the underlying code for GPT-3 hasn't been released yet to the public. GPT-3 is capable of some impressive and perhaps spooky NLP feats, such as writing documents in poetry, conducting question answering, solving math problems, even doing software development. This has led some observers to question the potential obsolescence of certain human professions. But I'm not so sure. Before we talk about this further, let's discuss GPT's training in more detail. The creation of GPT-3 entailed $4.6 million in terms of the training cost of the compute resources. That's equivalent to 355 GPU years of NVIDIA's most powerful GPU. Translated into the carbon footprint, it's estimated that GPT-3 results in the same impact as about the lifetime emission of 5 or more cars. These figures refer to just the training costs, so that's not including the costs of research and development or the inference that's being done using this model. Okay, so what is going on with GPT-3? Why is there so much obsession and excitement about this model? Stuart Russell, who is the lead of the Center for Human-Compatible Artificial Intelligence at UC Berkeley, summarized the situation as follows. Artificial general intelligence is not going to be reached by just having bigger deep learning networks and more data. I don't think deep learning evolves into AGI. GPT-3 is like a rocket ship that's sitting on a launch pad. It's spouting an impressive amount of smoke and fire, but it's not progressing us towards the dream of artificial general intelligence. It's not clear that this form of bigger and bigger NLP models is going to progress us towards a model that really understands anything about the world in which it exists. So it's pretty clear that I take a pretty skeptical lens on these latest advancements within NLP. I think there are 3 problems here. First, these developments are unsustainable. If you look at the carbon cost and the cost to train the models, it's really limiting development to a subset of elite firms. Second, GPT-3 hasn't even been released open source to the research community yet, so it's difficult to audit or learn from it more broadly. And then third, we've talked about how this model is potentially distracting from the ultimate goal of pursuing an AGI. In terms of where we go from here, there's speculations that companies like OpenAI, DeepMind, Google Research, even Amazon's AWS, that they're going to continue to pursue these bigger and bigger models because of the journalistic hype surrounding these advancements. We haven't really discussed yet the underlying rationale for the pursuit of bigger and bigger models, namely profit. All these companies stand to benefit from the paradigm of GPU-based training. But what if massive machine learning models is not the only path forward? What if there's a way for small players to continue to innovate, drive forward in progress on machine learning? Well, based on my understanding of the field, I'm seeing an orthogonal movement towards smaller and more nimble machine learning frameworks, as well as associated computing hardware. One technique that falls into this category is pruning, which refers to the removal of unnecessary weights after training and before inference. For many models, it's possible to sparsify up to 95% and achieve comparable performance. Pruning and sparsification is a frequently used technique for improving model performance and compute demands during runtime. A real innovation in terms of smaller and nimbler machine learning frameworks came with the release of the lottery ticket hypothesis paper in 2018. A pair of researchers determined comparable performance could be attained using a mini neural network that was present within any sufficiently parameterized network. This finding has exciting implications for further research into the presence of these subnetworks that are smaller, faster, and easier to train. One final alternative to the Supersize Me models that I want to touch on is the possibility of rewriting algorithms for commodity hardware. It's not necessarily the case that machine learning has to be done on GPUs. There are some advantages, like a larger memory, for CPUs, not to mention the fact that they represent commodity hardware, democratizing access to NLP and other machine learning algorithms. Just to wrap things up, I've written a bit about my opinions on artificial intelligence, specifically the detrimental use of this phrase that I think is overly broad and overly applied. I'd also encourage you to check out this YouTube video, Is AI Deepfaking Understanding?, where Joshua Bach really improved my understanding of machine learning and how these recent advancements kind of impact human capabilities and our future relationship with an AGI. That's it. You can find me on pretty much all of the socials at Nicole Janeway, and I particularly love writing for Medium. So if you enjoyed this talk, you can find more content about data science on the Medium platform under Nicole Janeway. All right, thanks for watching.